So we're going to be speaking for the next 30 minutes about quantum computing in APAC. Now, first thing I want to say is APAC is a really big place. And to be honest with you, I think sometimes those of us who do travel forget just how big it is. So with that said, we're not going to be able to cover every single quantum effort in the region. And in fact, we're going to have probably a little bit more of a hardware discussion today. We'll bring in a few of the other things. But really to start, I'm going to let you introduce yourselves, please, if just start. And who are you? Where are you from? And why are you here?
Okay, I am No-Weon Kang from South Korea. The name of my institution is KRISS, and I am the director of policy and technology services. I lead the one project. The name of the project is Quantum Computing, Quantum Transformation, a Scale-up Valley Development Program. Yeah, it's a very long name, but anyway, is it related to the quantum ecosystem? So I want to build a ecosystem of the quantum parts and equipment and material. Yeah, thank you.
Hi, my name is Jaegyoon Hahm, and I'm also from South Korea, and I'm from KISTI. KISTI is one of the national institute in Korea, and KISTI has is the computing service provider very long time. Actually, we regularly procure the national scale supercomputer and giving access to all of the users researchers in Korea. In quantum, actually we recently started a government project in which we will procure a quantum computer in our site, and then we were making hybrid with our supercomputer and giving the cloud service to the research and development users in Korea. And I'm in charge of the project, and I think that's why I'm here. Thank you.
That's good to know.
Thank you, everyone. My background is slightly different. Actually, the company and I are based in California and Singapore. So my background and my co-founder's background, actually, we all came from Oscar Penter's group before he became AWS. So, and myself also work at the Berkeley National Lab and UC Berkeley as a postdoc with Irfan Siddiqui, who is also pioneer of superconducting circuits. And so the company was founded on the essentially legacy of both institutions in California, and our lab is also next to Berkeley. Our engineering team, which takes actually majority of our headcount, is based off in Singapore. So the US side is science team, and the Singapore side is engineering team, and the delivery team, and the production team. So I think a couple years ago, because we see that, because I'm Asian, we say that Asian market has a tremendous amount of engineering expertise, and also my performance Singaporean. So we see the partnership with A-Star and other institutions in Singapore is very fruitful. So we just got it there. So after we started a company called Anyon Computing in US, 6 months later, we actually incorporated in Singapore. And since then, since 2021, we have been a cross-Pacific company, so-called APAC. Trust me, I fly so many times to Singapore, I get the pain of how big the ocean is. And yeah, and we work with Korean partners, Singaporean partners, and other partners in the region, including Taiwanese, so that we can be able to integrate and build the solid quantum computing foundations and infrastructures for the region, in the region. Of course, as I say, that we are cross-Pacific, so a little bit hybrid. I think thank you very much for bringing me here. I'm kind of in the middle of a definition of APAC.
And I just want to thank you, Natasha, for organizing this panel, for bringing everybody together, and me to speak today.
Hello, everyone. My name is Natasha Kovacs, and I am the head of strategy at STT. STT was founded in 2017. We hold the unique and possibly unenviable position, considering there's less ecosystem, of being the only private hardware provider in South Korea. And I also am personally on the government advisory board for Malaysia as well, because we do, for Quantum, we do business around the Asian area. We build a lot of the surrounding hardware ecosystem around QPU with providers such as from Anyon. We also help with integration for the HPC or other tools that are being used in Korea, such as with KISTI or with Megazone and Naver Cloud, etc. And so basically, STT kind of builds itself as a quantum ODM. So anywhere that we can fit into the supply chain, use Korean engineering and Korean expertise, we kind of help build out solutions for that.
Good afternoon. My name is Shintaro Sato from Fujitsu. I'm actually head of the quantum lab at Fujitsu. As you may know, Fujitsu is a computer and service company. We have been developing the supercomputer for years. Okay. Now we started quantum computing several years ago. And basically, we try to cover all the technology layers of quantum computing, from device level, platform, error collection, algorithm, application, everything. And as for hardware technology, we work on mainly two technologies. One is superconducting qubit technology with weekend. The other is diamond spin qubit technology with T-Delft. And for we have a booth. We have booth upstairs. As for the superconducting qubit technology, we just developed a 256 qubit quantum computer this April. Now we are building 1,000 qubit system. Hopefully, we can release that next year. But anyway, if you have any question, please let me know. I can answer. Yeah.
So if you'll hold that, please. So I'm going to break this down roughly into 3 areas of discussion in the time we have. First, I want you to talk a little bit about hardware. So this will be, by my count, there are about 86 quantum hardware companies in the world. Actually 85, because Oxford Ionics is now officially part of IonQ. That's a lot of quantum computing hardware companies, right? The second part is we'll talk a little bit about software, right, and how that affects what you're doing. And from your organizations, but also, if you will, please, more from a larger APAC perspective. And then finally, I want to talk a bit about sovereign issues. So what you really think of as quantum computing, let's say, being important to your country, and the region, of course, you can as well. Is it just the next thing? I mean, Fujitsu obviously is, you're building your own systems, as are others. Some countries in the world seem to be very happy just to get a quantum computer from somewhere. Others say, we are building our own. Thank you very much, right? So let's start with hardware. So you started talking about supercomputing, and there was some recent news, right, with Fujitsu.
Yes.
You're homegrown, right? The U.S. headlines, quantum computer. Why do you think that's so great?
I mean, actually, we work on the superconducting technology.
Yeah, what I meant to say superconducting.
Superconducting.
Did I say supercomputing?
Superconducting qubit technology. But at the same time, as I said, we also work on different technology, downspin. The reason is I believe we don't know the final solution yet. So we don't know the future yet. So that's why we work on the two different technologies. But at this moment, superconducting technology is most matured. That's why we really want to build a system using that technology. But it's not for ourselves, it's for our customers. So we like to help the customer solve their problem. So that's how we, communicate with our customer using HPC technology, and also for the quantum technology, the same thing. We just try to solve the customer's problem. So whatever hardware, it's okay. But we really have to provide a really good technology, best technology to our customer. That's what I'm thinking. So at this moment, we work on the seriously superconducting qubit technology, but in the future, we may want to work on different technology too.
Look at some others. Yeah. So, okay, I have to keep saying superconducting.
It's complicated.
I'm doing another panel later, which is on supercomputing. Natasha?
So just talk about the hardware in general?
Just what's your favorite? What are you focusing on? What's your predictions? I mean, from your organizational perspective.
Yeah, so SDT takes a somewhat more agnostic approach. We work with trapped ions, silicon spin, neutral atoms, and superconducting, not supercomputing, although we've done that as well. But I think that, as our friend here from Japan has said, that superconducting is the most mature, and it's what we're really going all in on right now. In fact, building out a JV partnership with Anyon to commercialize these and manufacture them around the world. We are currently installing a computer next month, and we've actually just sold one, which is really exciting, and we should talk about that later. And so we really think that from a hardware perspective, Korea has expertise in semiconductor. They're good with FPGAs and maybe with manufacturing certain precision parts. And so I think that we want to somehow find the right niche as a country to continue to grow and maybe dominate a certain portion of the supply chain. I don't know if Korea has necessarily found that spot yet because it's still somewhat immature. I don't think. I mean, although Korea was one of the first countries in the world, I think the first 5 or first 10 to actually have a national quantum policy, it's still somewhat immature as a country. We're still sort of catching up to other countries' QPU development. And so I think there's a lot that Korea can do to bring more of what we have already made the best of in the world to quantum computing. So SCT is hoping to try to fill that niche.
Okay, Roger. So Roger, let me just say, there are 2 companies that start with the word Anyon. Endlessly confusing. So
yeah, I get that point.
Help us clarify exactly what you're doing.
So let me start with a great Anyon question. So the first time I learned about Anyon was when I was in Caltech. Was one of the first person in my Oscars group, with experimental science group, to take Presque and Alexei Kitayev's class on quantum computing and quantum error correction. That was when iPad Pro was initially launched, because that whole class was taken with the notes was taken down my first iPad Pro. So it's 2017. So I learned from the class that if you want to do photon gate, protected gate, you essentially leverage this emerging phenomenon or emerging particle out of the a lot of qubits, which is called Anyon. And so that's kind of association of photon and quantum computing, error correction, and with Anyon baked into my brain. So when we started to have a company, first of all, having a company in Oscar's group, this work popped. And we decided to call ourselves Anyon Computing. Oscar has a slightly different idea, but it's all started with A.
Okay.
So what happens like this? So we chose this name because there's a lot of Caltech footprint onto it, because Kitaev, who invented the error correction surface code, was actually in Caltech. It's also where we learned about Anyon first hand. So we use that name. Okay. That being said, so we have the American or Singaporean Anyon, and there's a Canadian one, so we're different companies, completely different ones. And so coming to what we do, so my background, when I joined Oscar's group, we're actually doing quantum photonic chip. So all Nature Science paper were actually quantum photonic chip from Caltech. But Oscar started to pivot to superconducting circuit because we see so much, actually tremendous amount of capabilities that you can use the superconducting circuits to do quantum experiments. So we are in quantum superconducting circuits, not because we started doing that, actually because we see the advantage of it. We pivoted. And so Oscar now is doing full superconducting with AWS. And then I later joined Arfan Siddiqui's group who is a pioneer of superconducting circuits and doing all kinds of superconducting qubits from Transmon, Fluxonian, CAD qubits, and GKP qubits, you name it. So with tremendous amounts of knowledge, expertise, and know-how for the last more than 10 years of experience, we decide, I think that's it's most appropriate as a company to solve the key problem of deploying, help data centers and computing centers to have a quantum hybrid backend. And with that in mind, our field customer will be just hyperscalers. So we focus on how to scale it up. So we take the most mature platform, which is Transmon superconducting qubits, and improve on the connectivity and the gate architecture of it. And then we were actually one of the first ones to do large-scale modular quantum computing with a quantum network between multiple chips. That was our 2021 work initially started. And I actually presented that to someone in DOE. And since then, we have been focusing on building superconducting chip, but in a way that they are modularly connected and entangled with high fidelity, such that you can build a large scale, like 1,000 qubit, even 100,000 qubits Q system with just like modular connections. So that way also came from the fabrication, because we are fab guys. We know it's impossible to fabricate a multi-thousand qubit chip with high yield. Just not possible. And so with that knowledge, so we built the chip. And we also have the technology to build a system on top of it, including the cryogenic integration, shielding solutions, thanks to our Berkeley expertise. And we also have the know-how to how to utilize FPGA to build a control system out of it. So we naturally also have that IPs, and that's what our engineering team in Singapore does. And also work with the Korean partners to manufacture over there. So as I mentioned that, we do have a lot of expertise, and in the US team focus on the science piece, which is the quantum part, and then the other rest of it is going to be partnered with the Asia Pacific market partners.
Okay. Thank you.
Okay, I think all of the panelists, except me, is providers for quantum computer, and actually I'm the consumer. Okay, so
you have to listen to him.
Exactly.
Yeah. Actually, our project is the first, the big project funded by government, Korean government, to buy the quantum computer. And actually, similar project is ongoing in many countries, like Japan and many countries in Europe. They are procuring the quantum computers and connect it to their supercomputers. And actually, in Korea, I think Dr. Kang may talk about their project, but in Korea, actually, there are a project ongoing to make a homegrown quantum computer by government, actually. And yes, we can use it, but we cannot wait until that is produced to the market. So I think the importance is we need to chase two rabbits. We need to secure homegrown core technologies, and also we need to grow the application market, because the impact is much more bigger for the software than hardware, we think. Mm-hmm. And the KISTI has a role in Korea, making that application market and make application ability in supercomputing area. And also we think in quantum area, we need to make many researchers to be ready for really commercial quantum computer. So that's why we are starting this project, and we want to very stable quantum computer service with our supercomputing infrastructure.
Thank you.
Yes.
So, as already Dr. Hahm said, my institute develop quantum computers the modality is supercomputing and superconducting. No,
See, it's contagious.
Yeah, you're right. So superconducting and neutral atom type. So actually, that quantum computers are homegrown one. So the other part of my interest is about the global supply chain. As you well know that the quantum computers major part is from the traditional industry. So actually, Korea is a powerhouse of semiconductor and telecommunication and optical industry. So we have a very strong industries for the equipment and part and material. So I want to transform this industry to the quantum technology. So to help them, so we provide some researches related to that, and we transfer our technology to the industry, and we also make a open hub for the quantum technology ecosystem. So we want to promote our companies to the quantum technology. And the last one is that I think global cooperation is very important for us. Actually, we are Asian Pacific countries has various kind of technologies all over the world, so we can help each other. So that's the main purpose of me to participate in this conference.
So I think we get the idea that Korea wants a homegrown quantum computer. And not just a small one, right? There are many, I'll say small, I'll be polite, small quantum computers in the world, but eventually we need one that is big enough to fulfill all these promises people have been making about. So I will give that to Korea, that you want that. What about Japan? Is there the sense that you must have a homegrown, fully powerful, fully capable machine?
I believe that, Japan needs not only quantum, high performance computing technology. Yeah. That's why we work on the supercomputer and the quantum computer
I'm so
too.
Sorry.
Then the high performance computing technology is very important for national security, I believe. Mm-hmm. So anyway, the quantum computing is one of the examples, okay, one of the candidates for the future computing, right? So we should be, always looking for the new technology for the, improve the computing to realize a higher performance computing technology. Mm-hmm. So anyway, in that sense, it's very important. High performance computing technology, including quantum computing, is very important for national security.
That's a good framework, not quantum in isolation. And let me just, if I may, put in a plug for our panel later today about quantum computer and supercomputing HPC integration. That's coming up in a couple of hours. We're almost at the hour. We've touched a bit on the sovereignty. I'm going to let you, though, have your closing remarks. Just touch on software very briefly, if you don't mind. We've talked about development in different modalities, so if you could maybe take a minute each and just emphasize, is KISTI good enough for you, or KRISS, or Penny Lane, or whatever, or how are you dealing with the software issue of how you will develop applications? And if you'd like to talk about control a little bit, that's fine. But is there something specific in terms of your strategy that you're going after?
Anyway, I believe software technology is very important. Could be more than important than the hardware technology, as important as the hardware technology. Anyway, we are now being a platform, which not only for our superconducting quantum computer, but we have another technology, like downstream quantum computer. So we'd like to use the same platform. We would like to provide the same platform to our customers. The customer can choose which quantum computer they want to use, right? So we want to expand that to the other hardware technology too. Right? Mm-hmm. So, because our purpose is to help customers solve the problem. So anyway, if the other computing technology is available, I'm happy to collaborate with them. So for us, the global collaboration is very, very important. So anyway, also to build a platform, we don't think we can do it alone. So we do a collaboration with the University of Osaka. Actually, we are make a OSS platform software very recently. So we are very happy to work with many researchers all over the world to develop such a technology. Anyway, the important thing is we should provide a good technology for our users. So that's what I believe.
Thank you.
Yeah.
Okay, so just a few thoughts on software.
So SDT does produce a software platform as well, because if we are, providing quantum controllers, if we're providing full stack computing, we need to be able to connect to it. It's called QRISS. I do think what's really interesting is that from a user perspective, who cares what's under the hood? We don't care if our phone is running AMD or Intel. We just care that we can look cool while we're doing it. So
There's no one from Intel and AMD here, I know.
as a user, not as a technologist. So I think that software is very important. And I personally don't. What's really interesting is that around the world there are so many quantum software providers now, because it's very easy to get started comparatively to quantum hardware, because you need just financially you just need a ton of money to even buy a single quantum controller. So it's really hard for startups to work on it. So that means that now quantum startups are focusing on quantum software, which means that hardware providers like ourselves don't necessarily need to focus on it. So strategically, from SET's perspective, although we provide a platform that allows access, I don't think that we need to go into all of the functional details that our users may want to use. And so we really, really think that we can cherry pick like best software providers from around the world. We can work with those who are specializing in algorithms, those who are specializing in making it really easy to program gates, et cetera, and just add them to our platform. And that's something that saves us a lot of time and money. And
Okay.
yeah.
I'm going to. So you each have 20 seconds.
Yeah.
Oh, I'm so sorry.
That's okay.
I'll be short. Software for us, it's a place we welcome partners to work with us on.
Okay.
Our existing partner include A-Star and NVIDIA. So if you notice that among the first five physical QPU providers to NVIDIA, it's Kodak Q platform. So we rely on the partners to offer the software layer integrations, SDKs above us.
Okay.
Actually, we have a long history of experience in supporting computational science users. I think in quantum area, to increase more users, I think in classical area, there are very thick of software stack, very deep and thick. And quantum is now started, and it's very shallow, I think. So most important thing is to make it more software engineers to bring in and make more compilers technologies and libraries for users, and make it more easier to use the quantum computer is the most important thing.
One sentence. Yeah. You see how this is working.
Okay, so we are concentrate and providing a platform. Quantum computer is the most basic one, so we provide a platform.
Thank you. And please thank our panelists for joining us today.